Good morning.
Good morning.
Could you please tell me your name?
My name is MD Arifur Rahman.
Okay. What is your home country?
I'm from Bangladesh.
Okay. And what is your major?
I'm doing my PhD in civil engineering, especially in water resources engineering.
Okay, thank you. Why did you choose to study this major in the United States?
Yeah, because when I completed my undergraduate study in my country, and I have completed this degree from Bangladesh University of Engineering Technology, and I have seen a lot of teachers and students. They came to this country previously, and I also learned from internet that the USA is the best country in the world, and they have the facilities of research which is really cutting edge, and we can do something which is really important for the society and for the environment as well as an engineer, and as a water resources engineer especially.
All right, thank you. So now I'm going to give you your list of 40 by 40 words. Please read the ones that are highlighted in pink.
And pink. Aqueduct, perimeter, hydraulic, roughness, intensity, diagram, asymptotic, alternate, critical, property. And the general academic keywords are classify, difference, requirement, element, irregular, computation, equation, potential, variation, understand. What's this?
Thank you. So now I'm going to ask you to define two words for me.
Right.
Okay, so the first one is flood.
Yeah, flood is something that we know that when the water is stagnant at some place, we call it flood, but especially the definition is different from this. When the stagnation of water creates intervention or problems in daily life, then we can call it flood. And sometimes flood have some negative impact on society and human life, but most of the cases the flood also have some benefits, because when water flooded or river gets flooded, it just carries sediments that is very fertile, that improve the fertility of the land, and at the same time we cannot manage the flood. It creates damages to our property and lives as well.
Okay, all right, thank you. Next word is elevation.
The elevation is measured something, it is a kind of height that is measured from a specific reference level, especially from the mean sea level. If we want to calculate the depth of water or river elevation. But for other cases, like for the elevation of a building or something like that, we have like the top of a road, we have a different reference point. But most of the cases we use mean sea level to measure the elevation or height of a point.
Okay, all right, thank you. So next I'm going to ask you a question. Okay,
yes.
So this question is, what do you dislike about being a graduate student?
Yeah, there is a point that as a graduate student we need to produce some results, and I'm doing research, for example, in hydrology, but since I'm doing a research, the result is sometimes unknown. But my professor, he always pushed me to produce results every week, and every student has the same kind of problem that I face. But at the end, when I produce some results, it is good. But that is kind of instant pressure that I am facing every week. This is the thing that I really dislike to be a graduate student.
Okay. All right, thank you.
Yes.
Okay, so now I'm going to ask you 3 questions from your previous teaching lessons.
All right.
The first one is, why do different materials have different roughness factor?
Yeah, in the real world case, we have roughness means it is the irregularities of the surface. For example, glass. Glass is the most smooth surface in the world. And if we just consider a surface which is covered with rocks, it is rough. That's why the velocity of water or the energy of water gets reduced on the surface. So if these irregularities and roughness also varies with the arrangement and the density of this irregularities. That's why it varies from material to material. And each material has different types of coefficient. For example, the Manning's N, if the value is low, that means the roughness is low. And if the value is higher, the roughness is higher compared to other surface.
Okay, all right, thank you. Next question, what is a critical flow?
Yeah, critical flow is the most important flow. So at the critical state of flow, it has some specific properties. Like the Froude number. Froude number is a number that measures whether the flow is critical, subcritical, or supercritical. When the number is 1, we can call it flow is critical. At the critical state of flow, the specific energy, it is minimum, and the discharge, it is maximum. And also the velocity head, which is 1/2 of the hydraulic depth, and at the same time the specific force is also minimum at the critical state of flow. And if you consider any rectangular canal or channel at the critical state of flow, the specific energy or the critical specific energy will be 1/2 of the depth of water. This is the property of a critical flow.
All right, thank you. Last question, what are the different flow profiles in open channel?
Yeah, if the flow is not uniform, that means it is a gradually varied flow. So for most of the real world cases, the flow is gradually varied flow. And there are 5 types of channel slopes. It is a mild, it is steep, it is critical, it is maybe horizontal, or it may be adverse. And we have 13 different types of flow profile, depending on these different types of channel slopes. Right? If, for example, if the channel slope is mild, then the normal depth, it lies above the critical depth line. Then the flow profile is different. It may be a drawdown, or it may be backwater effect. For example, at the upstream of a dam, the flow profile is backwater effect. It has a profile which is gradually varying from the dam side to the upstream. That's why we need to calculate this thing. And if the slope is like steep, so the profile is different. There will be supercritical flow. The energy is higher. That's why we need to construct different types of stilling basin to reduce this flow and to make it again subcritical flow.
Okay, all right, thank you.
Okay, thank you very much.